The simulation hypothesis or simulation theory proposes that all of reality, including the Earth and the universe, is in fact an artificial simulation, most likely a computer simulation. Some versions rely on the development of a simulated reality, a proposed technology that would seem realistic enough to convince its inhabitants the simulation was real. The hypothesis has been a central plot device of many science fiction stories and films. There is a long philosophical and scientific history to the underlying thesis that reality is an illusion. This skeptical hypothesis can be traced back to antiquity, for example, to the butterfly dream of Zhuangzi, or the Indian philosophy of Maya. A version of the hypothesis was also theorized as a part of a philosophical argument by René copyright Descartes. Many works of science fiction as well as some forecasts by serious technologists and futurologists predict that enormous amounts of computing power will be available in the future. Let us suppose for a moment that these predictions are correct. One thing that later generations might do with their super-powerful computers is run detailed simulations of their forebears or of people like their forebears. Because their computers would be so powerful, they could run a great many such simulations. Suppose that these simulated people are conscious, as they would be if the simulations were sufficiently fine-grained and if a certain quite widely accepted position in the philosophy of mind is correct. Then it could be the case that the vast majority of minds like ours do not belong to the original race but rather to people simulated by the advanced descendants of an original race. It is then possible to argue that, if this were the case, we would be rational to think that we are likely among the simulated minds rather than among the original biological ones. Therefore, if we don't think that we are currently living in a computer simulation, we are not entitled to believe that we will have descendants who will run lots of such simulations of their forebears. In 2003, philosopher Nick Bostrom proposed a trilemma that he called the simulation argument. Despite the name, Bostrom's simulation argument does not directly argue that we live in a simulation. Instead, Bostrom's trilemma argues that one of three unlikely seeming propositions is almost certainly true. The fraction of human-level civilizations that reach a posthuman stage, that is, one capable of running high-fidelity ancestor simulations, is very close to zero, or the fraction of posthuman civilizations that are interested in running simulations of their evolutionary history, or variations thereof, is very close to zero, or the fraction of all people with our kind of experiences that are living in a simulation is very close to 1. The trilemma points out that a technologically mature, posthuman civilization would have enormous computing power, if even a tiny percentage of them were to run ancestor simulations, that is, high-fidelity simulations of ancestral life that would be indistinguishable from reality to the simulated ancestor. The total number of simulated ancestors, or sims, in the universe, or multiverse, if it exists, would greatly exceed the total number of actual ancestors. Bostrom goes on to use a type of anthropic reasoning to claim that, if the third proposition is the one of those three that is true, and almost all people with our kind of experiences live in simulations, then we are almost certainly living in a simulation. Bostrom claims his argument goes beyond the classical ancient skeptical hypothesis, claiming that we have interesting empirical reasons to believe that a certain disjunctive claim about the world is true, the third of the three disjunctive propositions being that we are almost certainly living in a simulation. Thus, Bostrom, and writers in agreement with Bostrom such as David Chalmers, argue there might be empirical reasons for the simulation hypothesis, and that therefore the simulation hypothesis is not a skeptical hypothesis but rather a metaphysical hypothesis. Bostrom states he personally sees no strong argument for which of the three trilemma propositions is the true one. As a corollary to the trilemma, Bostrom states that, unless we are now living in a simulation, our descendants will almost certainly never run an ancestor simulation. Bostrom argues that if the fraction of all people with our kind of experiences that are living in a simulation is very close to 1, then it follows that we probably live in a simulation. Some philosophers disagree, proposing that perhaps sims do not have conscious experiences the same way that unsimulated humans do, or that it can otherwise be self-evident to a human that they are a human rather than a sim. Philosopher Barry Dainton modifies Bostrom's trilemma by substituting neural ancestor simulations ranging from literal brains in a vat to far future humans with induced high-fidelity hallucinations that they are their own distant ancestors for Bostrom's ancestor simulations, on the grounds that every philosophical school of thought can agree that sufficiently high-tech neural ancestor simulation experiences would be indistinguishable from non-simulated experiences. Even if high-fidelity computer sims are never conscious, Dainton's reasoning leads to the following conclusion: either the fraction of human-level civilizations that reach a post-human stage and are able and willing to run large numbers of neural ancestor simulations is close to zero, or we are in some kind of possibly neural ancestor simulation. Some scholars categorically reject or are uninterested in anthropic reasoning, dismissing it as merely philosophical, unfalsifiable, or inherently unscientific. Some critics reject the block universe view of time that Bostrom implicitly accepts and propose that we could be in the first generation, such that all the simulated people that will one day be created don't yet exist. The cosmologist Sean M. Carroll argues that the simulation hypothesis leads to a contradiction. If a civilization is capable of performing simulations, then it will likely perform many simulations, which implies that we are most likely at the lowest level of simulation, from which point one's impression will be that it is impossible to perform a simulation, which contradicts the arguer's assumption that advanced civilizations can most likely perform simulations. Some scholars accept the trilemma, and argue that the first or second of the propositions are true, and that the third proposition, the proposition that we live in a simulation, is false. Physicist Paul Davies deploys Bostrom's trilemma as part of one possible argument against a near-infinite multiverse. This argument runs as follows: if there were a near-infinite multiverse, there would be post-human civilizations running ancestor simulations, and therefore we would come to the untenable and scientifically self-defeating conclusion that we live in a simulation. Therefore, by reductio ad absurdum, existing multiverse theories are likely false. Unlike Bostrom and Chalmers, Davies, among others, considers the simulation hypothesis to be self-defeating. Some point out that there is currently no proof of technology which would facilitate the existence of sufficiently high-fidelity ancestor simulation. Additionally, there is no proof that it is physically possible or feasible for a post-human civilization to create such a simulation, and therefore for the present, the first proposition must be true. Additionally, there are proofs of limits of computation. Economist Robin Hanson argues a self-interested high-fidelity sim should strive to be entertaining and praiseworthy in order to avoid being turned off or being shunted into a non-conscious low-fidelity part of the simulation. Hansen additionally speculates that someone who is aware that he might be a sim might care less about others and live more for today. Your motivation to save for retirement, or to help the poor in Ethiopia, might be muted by realizing that in your simulation, you will never retire and there is no Ethiopia. A long-shot method to test one type of simulation hypothesis was proposed in 2012 in a joint paper by physicists Silas R. Bean from the University of Bonn, now at the University of Washington, Seattle, and Zoré Davudi and Martin J. Savage from the University of Washington, Seattle. Under the assumption of finite computational resources, the simulation of the universe would be performed by dividing the continuum spacetime into a discrete set of points. In analogy with the mini-simulations that lattice-gauge theorists run today to build up nuclei from the underlying theory of strong interactions, known as quantum chromodynamics, several observational consequences of a grid-like spacetime have been studied in their work. Among proposed signatures is an anisotropy in the distribution of ultra-high-energy cosmic rays that, if observed, would be consistent with the simulation hypothesis according to these physicists. Besides attempting to assess whether the simulation hypothesis is true or false, philosophers have also used it to illustrate other philosophical problems, especially in metaphysics and epistemology. David Chalmers has argued that simulated beings might wonder whether their mental lives are governed by the physics of their environment, when in fact these mental lives are simulated separately, and are thus, in fact, not governed by the simulated physics. They might eventually find that their thoughts fail to be physically caused. Chalmers argues that this means that Cartesian dualism is not necessarily as problematic of a philosophical view as is commonly supposed, though he does not endorse it. Similarly, Vincent Knitzer has used the following computer simulation scenarios to illuminate further facts a circumflex euro facts that do not follow logically from the physical facts a circumflex euro about qualia what it is like to have specific experiences, indexicality what time it is now and who I am, and personal identity. Imagine a person in the real world who is observing a simulated world on a screen, from the perspective of one of the simulated agents in it. The person observing knows that besides the code responsible for the physics of the simulation, there must be additional code that determines in which colors the simulation is displayed on the screen, and which agent's perspective is displayed. These questions are related to the inverted spectrum scenario and whether there are further facts about personal identity, that is, the person can conclude that the facts about the physics of the simulation, which are completely captured by the code governing the physics, do not fully determine her experience by themselves. But then, Knitzer argues, imagine someone who has become so engrossed in the simulation that she has forgotten that it is a simulation she is watching. Could she not still reach the same conclusion? And if so, can we not conclude the same in our own daily lives? Thanks for watching.